I'm Anil Kumar, and in this particular video we'll kind of talk about composition of functions, and I'm taking this as my cover video for hundreds of videos on the related topic. So we'll also provide you with links so that you can go and have an access to what you really want very easily, since I can't really arrange my videos on YouTube, and we have hundreds of videos now on logarithmic functions. So when we talk about composition of functions, we are thinking about g of f, we are thinking about f of g. Remember one thing, composition of functions is always between two or more, right? So there could be more. We could write of h also and so on, correct? But for simplicity, we'll take two at a time. Now this nomenclature is also used like f of g of x, correct? Kind of like this also you can write, and at times we also write this as f of g and then we write x outside, but all of them mean the same thing, correct? So whenever we are talking about composition of functions, we are talking about all this. Now let me also tell you what we are not talking about. We are not talking about these operations, right? We are not talking about g minus f. We are not talking about product, okay? We are not talking about division, right? We are not talking about these. Why we are not talking about these? These are not compositions, these are combinations, okay? So these are combinations. For that, there's another set of videos, and I'll provide you with that link here. So that's a different playlist altogether. So not this for the time being, okay? All this is composition. So when I say composition, we are trying to do a function after another function. So here the key operation is that a function followed by another function, okay? That is key here, and order is important, right? Order is critical. That is very important. Here some of them are commutative. I will not say these are, but some of them are. But order is not all that important in this case. In this case it is highly important. At times you just get absolutely wrong result if you do not follow the order. So it's always from inside out. So the order is inside out, correct? So we'll have examples based on this and give you links to those. Another important things which we observe in composite functions, that if we have one-to-one relation, right? In that case, f of f inverse is always equals to x, right? So inverse of the function, if I try to do that composite function, and that could be either way, and that is also equals to f inverse of f, right? So that is also very important to understand. In case of composite functions, always if we have one-to-one relation, in that case f of f inverse is equal to x and is equals to f inverse of f, right? So composition of a function with its inverse, right, is equal to x. So let me write here, composition with inverse is x. So whatever you feed in, that's what you get out, right? Now that is very critical, but another very important thing which you should consider here is the domain and range, right? So consider the domain of these functions, right? So there are of course restrictions here. When I say f of f inverse is x, x is a straight line that will not have any restrictions. However, when we do composition of the function, there will be restrictions based on the functions themselves, right? So the composition with inverse is x, but the restrictions of f is applied there. So domain of these is, so that means what you have to look for is restrictions on f, right? So that should be that is applied on the result of composition of function with its inverse. So I'll provide you links with this also, correct? And then we will talk about some applications, right? So when we say applications, then in many applications you will find relation between one formula to the other. So formula based applications, so some could be formula based applications. For example, you may find relation between distance and time, and then you can find relation between distance with distance, and then relate the other one with time. It's kind of like that, right? So formula based applications could be there, and then there could be other real life situations. So based on that, I'll give you few links, right? That is one thing. And one of the most important things which we are going to also consider on composition of function is how to form composite functions. And then how to write or how to evaluate these functions and their domain and range. So these are few things which we are going to consider, and in this particular video I'm only going to give you links for all these things so that you can get to those functions and then see just what you need at with minimum effort, right? That's the whole idea. And then in the next part we will consider inequalities. So in inequalities we will take up both composition and combination. Okay, so that will kind of combined together. So I'll give you some relations, and then we'll see how to work out inequalities with reference to composition of functions. And then with all this we will then look into different functions. So inequalities when we are considering different functions, right? So we'll see how one function interacts with the other. For example, we could have linear combination. Okay, we could have linear quadratic, right? We could have quadratic with quadratic, or we could have log with exponential, likewise, right? So whole range of combinations we will consider in the set of videos. So I have about more than 100 videos on this topic. I hope this particular kind of index sheet helps you to get to the right one. So come back to this sheet whenever you're looking for searching for something, and that should give you a link to what you really need to know. I hope that helps. Thank you and all the best.